Okay, for my review topic for test number 2, I'm doing web work number 8, question 2, undetermined coefficients. So basically we're solving this differential equation, y double prime minus 4y prime plus 4y equals e to the 2x. So for the question itself, the first thing it was asking for was find the general solution. So to find the general solution, we're basically just going to factor this out, set it equal to 0. So go through the whole steps. E to the mx equals y squared minus 4y plus 4. Set it equal to 0, and then we'll factor that out to be y minus 2 squared equals 0, y equals 2, and we make that m's. Just be consistent. So then our m1 equals 2 and our m2 equals 2. So since we have the same answer, we're at a double prime, so we know we need 2 different solutions. So when we go to do that, we're going to add the x to the c2 values. So c1 e to the 2x plus c2. This is where we'll add the x to get a different solution. So there's our general solution there. That's our y to c. Now for our particular solution, this is kind of a step that threw you off to begin with, or threw me off at least. So I left this part blank and then went ahead and did the derivatives of it. But to find our particular solution, if we look back at our notes of this chart here, our form for our particular solution is e to the 2x. So on our chart, here e to the 3x is the same form, so we're looking for the form a e to the 3x. So if we go with that, a equals, or a to the 3x ends up being the same as our c1 e to the 2x. So we can't use that because it will get the same solution. So if we can add our x and do ax e to the 3x, but then again we'll also have our c2 x solution. So we're going to have to go a to the x squared e to the 2x, and that'll give us a new solution. So if we go ahead and derive those, we're going to get these solutions here, and then from there, to get our particular solution, if we look back at our original differential equation, y double prime minus 4y plus 4y equals e to the 2x. We're going to sub in our y double prime, which is this here, and then we're going to multiply negative 4 times our y prime, which ends up giving us this solution here. And then we're going to add or multiply our 4 times our y prime, which gives us this solution here, and set it equal to e to the 2x. Now from here, I'm going to go ahead and simplify this down. So we got our x squared, and x squared terms. So 4 is 8 minus 8, so these are all going to cancel out. And then we'll go to our x terms. 8 and negative 8, so these will cancel out. So what we're left with is 2a e to the 2x equals e to the 2x. So basically, we can just kind of ignore these, and 2a equals 1. Our a is going to equal 1/2. So we're going to plug this back into our y of p solution for A. So our y of p equals 1/2 x squared e to the 2x. So then to find our most general solution, is yc plus yp. So our yc up here was c1 e to the 2x plus c2 x to the 2x e to the 2x. Same thing with up here. And then our particular solution was the 1/2 x squared e to the 2x. And that will give us our general solution. Now, the reason why I picked this one was to make sure that when you're setting up your particular solution, that your general form isn't going to end up giving you one of your original solutions up here. So we had to end up going to the x squared form, which if this was y to the third, maybe, you know, we might have had to go cubed or, you know, anything like that. So you just got to be willing to keep going until you get away from one of your original solutions. And then from there, it's just kind of doing your basic math to get down to figure out your particular solution, and then to find your overall solution was to do your general solution plus your particular solution to give your most general solution. I hope this helps everybody, and good luck on the test. Thank you.